body of mass 7m lies on a smooth horizontal table. So nothing restricting the 7 here. It's connected to this pulley with a 5, a 2 and a 3. We let m equal 1 here. And we know everything that's going on in these questions are always just the same. So let's do our forces diagram. 7 is going to get pulled down by 5, 2 and 3, which is 10. So if we put in, or if we put in 7g, if we put in t for my first string, there's nothing going backwards for 7. So I can say t minus 0 is equal to ma, 7 times, well, let's look at my acceleration. 7's getting dragged that way with an acceleration of a. 5's going down that way with an acceleration of a. 3 is dragging 2 down with an acceleration of b and is going down also with an acceleration of a. And as 10 is dragging 7 down, that's going to be faster than 3 dragging 2 down. So it's going to be faster going, a is going to be faster for 2. So the acceleration for 2 is going to be a minus b. It's going down that way quicker than it's going up that way. So we have a minus b, a first and then b. So that should help us set up our equations. We'll put our a in. So t is equal to 7a. So now we have our 5. I have my t. I have my 2 strings, t1, t1. I have 5g. And I have my acceleration of a. So 2t1 plus 5g minus t, don't forget your minus t, is equal to ma, 5 times a. Then we have our 2. So we have t1. We have 2g. And our acceleration of a minus b. And it's going in this direction. Lower than it's going in this direction, with a minus b. So our equation is going to be starting with our 2g minus t1 is equal to m2 times a minus b. And then lastly, our 3 is going to have t2 attached, 3g. Acceleration of a plus b. So we can say that 3g minus t2 is equal to m times a. So we just multiply these out. 3g minus t2. Where did I get t2 from? t1. 3g minus t1 is equal to 3a plus 3b. And we have 2g minus t1 is equal to 2a minus 2b. So we need to get rid of t1s and we need to solve for a and b. So we can see our 4 equations here. So straight away I can replace t with 7a. That will eliminate t. Why don't we do that? So 2t1 plus 5g minus 7a is equal to 5a. So I'll just write equals 12a. So that's getting rid of t. Now I've multiplied my equations out. I've got 2t1, so why don't I multiply either of these by 2? I'll do this one here. I'll multiply this one by 2. So we're multiplying this guy by 2. So we're going to get 4g minus 2t1 equals 4a minus 4b. So we're going to get 9g is equal to 16a minus 4b. So we need another equation in a and b. So I need to get rid of this t1 here. And I think the best way is to just multiply this one by 2 as well to get 6g minus t1. 6g minus 2t1 is equal to 6a plus 6b, and I bring down my red one, 2t1 plus 5g is equal to 12a, so I get 11g is equal to 18a plus 6b. Now there's many ways. Sometimes you end up going down a route where there was a quicker way to do it, so here's where we're at with this one, but sometimes you do it a second time, you go, oh, I never saw that quicker way to do it. So we want to solve for a or b, so we have a minus b, so let's just multiply the top one by 3 to get 12b minus 12b, and the bottom one by 2 to get plus 12b. So we're going to get 27g is equal to 48a minus 12b, and with this one here we're going to get 22g is equal to 36a plus 12b. Combining these two, we're going to get 49g is equal to 70 and 14, 84a. 12 goes into both of them, or no, 7 goes into both of them to get 7g is equal to 12a. So we have a is equal to 7g over 12 meters per second squared. What were we asked in this question? A is 7g over 12. We were asked to show the acceleration of the 7m mass is 7g over 12, which was a. So we have this correct.